In this video, you'll be given a set of data, which you will make a scatter plot of. You will find the equation of a line using 2 points and point slope form. And then you will use technology such as a TI calculator to find a linear regression of that line. To start, we want to take a look at a set of data. In this particular case, we have the percentage of adults who access the internet by smartphone in the years 2009 to 2013. One of the things that we often do is instead of using large numbers like 2009, we set a starting year. In this case, we've set our starting year as 2009. So our X value is actually the years since 2009. Using the data, we would like to sketch a scatter plot, and you should use whatever scale you find appropriate using the 0, 1, 2, 3, 4, and label it on the axes. And remember to label your x-axis as the independent variable and your y-axis as the dependent variable. I've already done that in Desmos, and it looks like this. Now, I've used for my x-axis the independent variable, which is the year since 2009, and for my dependent variable on the y-axis, I've used the percentage of adults that use smartphone. I've plotted each of those 5 points. Notice I didn't use 0.31 or 0.43. I just used 31 and 43 as percentages because it's much harder for me to graph those decimals. But I've indicated that using my scale. So anytime that you're going to make a graph, it's very, very important that you label your axes and your scale. It would be very nice if I could have an equation of a line that kind of described what was going on here. And so the first thing that we're going to do is choose 2 points on this line. I'm going to choose 355 and 143. And I'm going to find the equation of the line through those 2 points using our equation for slope first and then our point slope form. Now I could choose any points that I'm given. I just happen to choose these 2. So the first thing I'm going to do is calculate my slope. 55 minus 43 over 3 minus 1. That's going to give me 12 over 2, or 6. Now in the context of this problem, what that slope indicates is that every year, the number of adults that use smartphones is going to increase by 6% per year. Now let's find that equation. We're going to use our point slope form. Y minus y1 equals the slope times x minus x1, and I would like to use the ordered pair 143. It's a good idea for you to indicate that somehow by highlighting it or writing a box around it so that you don't use an x from one coordinate and a y from another. So in this case, we're going to get y minus 43 equals 6 times x minus 1. Distributing, we get 6x minus 6, and then adding 43, we get y equals 6x plus 37. So we know that our slope indicates our rate of change. In this case, 6% per year. And our y-intercept here is where it's going to cross the the y-axis. So we're going to plot a point here. This is 35, so we're going to go 37 might be around here. I've got the other 2 ordered pairs there, and I'm going to draw a dashed line through those points. Now you'll notice that some of the other data points are either above or below, but are fairly close to that line. So finding the equation using point slope is a good way to do it if we're working with only a couple of data points. But sometimes we have a lot of data points and we want to take everything into account. And to do that, we find what's called a line of best fit, and we use technology in this case to do that. There is a very complicated formula to find the line of best fit, but we're going to use our TI 83 or 84 calculator. The directions on how to do this are the last 2 slides of this video. But just in general, let me write down a few steps. We're first going to use on our TI calculator the stat menu. And the first thing we need to do is edit a couple of lists. If you already have data in your lists, you should highlight the L1 or L2, hit clear, and then enter. Once you do that, into list 1, you can put your X values, 0, 1, 2, 3, 4, and into list 2, you can put your percentages so they line up. Then you're going to hit second quit to get out of that menu. We're then going to click stat one more time and arrow over to where it says calculate. And then we're going to go down to number 4, which says lin reg AX plus B. So that's going to be finding a linear regression using the data that we've already put in the lists. List 1 and list 2 are the default numbers. So if you have not put your numbers in list 1 and list 2, you'll have to put the L1, or maybe you use list 3 and list 4, you'll have to do list 3 and list 4 with a comma in between them to tell the calculator which lists to use. So I highly recommend you just use L1 and L2. Once we do that, we get this output. 7.6 for A, 32.6 for B. You may have an R squared. I'm not too worried about that. And then our R value is 0.99044 approximately. That means that our equation, because it has the form AX plus B, is going to be 7.6x plus 32.6. Now, what does that R value mean? The variable R is called the correlation coefficient, and a correlation coefficient of 0 means that there's no relationship between the first column of numbers and the second column of numbers at all. The closer we are to 1 or minus 1, the more perfect our linear relationship is. We also like to say that we might have a positive correlation that trends upwards from left to right, or a negative correlation that goes down from left to right. So when we're looking at these 6 examples that I've given you here, I'm going to put down some, and these are just guesstimates. A strong positive correlation would have a positive number close to 1, so we might have 0.89. The next one is weaker. It might have a correlation of 0.65. On the third one, we're going down. It may have a correlation coefficient of negative 0.9, where the negative indicates that it's trending down. Here we might have a correlation coefficient of negative 0.65. The fifth one here is moderate. It's not great, it's not bad. It might be right around 0.5. And then of course, our last one here, we might have a coefficient very close to 0 because there does not seem to be any correlation whatsoever. So for ours, because we had a correlation coefficient of 0.9904, we know that it's a positive, and it's very strong because it's 0.99, almost 1. So we have a strong positive correlation. The next slide I have here is a sketch of the linear regression, which we call the line of best fit. That's the one that we calculated. That's in blue. That's the one we used our calculator for. So this one was technology. And the dotted green line is the line that we calculated using the point 143 and 355. They are both approximations of a line that represents this data. The difference is that when we calculated, we only used 2 ordered pairs, and when we used technology, all of the ordered pairs were taken into account. Let's answer some questions based on what we've done. If we use the equation obtained by the calculator in problem number 3, what do we suppose the percentage of adults who access the internet with a smartphone will be in 2015? Well, we don't want to plug 2015 in for X. Remember, our X value was the years since 2009. So we're going to start with 2015 minus 2009 and get 6. Let me write down the equation that we did come up with. Y equals 7.6x plus 32.6. So now that we want to find the number of adults who use their smartphone in 2015, we will plug a 6 in for our X, giving us 78.2. To answer the question now, we would say that in 2015, we expect that 78.2% of adults will use a smartphone. Answering our next question, what do you suppose the percentage of adults who access the internet with a smartphone will be in 2022? So again, we're going to start with 2022 minus 2009. And in this case, we're going to get 13. And we will plug 13 in. 7.6 times 13 plus 32.6. In this case, we get 131.4. Now, because our Y value represents the percentage of adults, and we know we can't have over 100% of adults, this does not make sense. Why is that? Well, sometimes when we extrapolate too far past our set of data, then our model doesn't hold. So when we did 2015, 6 years, we weren't too far off. But when we went 13 years outside of our initial, we were really far out, and it appears that our model didn't hold. So it's interesting to ask yourself, what outside factors might influence the percentage of adults who access the internet in the years past 2014? Well, I would think new technology, either new technology or better technology, would affect that. We might not use smartphones in the future. Maybe we use something else. Also, you could have fluctuations in price if they become too expensive, or possibly they bring the price way down. Then we would be able to afford them more, and maybe more adults would purchase them. So lots of things could affect that. So to answer the last question, what would the danger be in using a linear model to explain this data, given your answers to number 6, and 7 actually, we might have something where it was linear for a while, but then because of new technology, it took off. In that case, our line would underestimate the number of adults. By the same token, if prices get so expensive and we are increasing for a while, we then might flatten out. And in that case, our line might overestimate. So we may either under or overestimate if we go too far past our data set. The next 2 pages are going to be the directions for using your TI calculator to do a regression. You'll have to pause your video to read them. I will leave them up for 15 seconds a page.